today, we're going through two sections today, okay? One deals with specific pairs of angles formed by a thing called a transversal. And then the next one is going to be using those and putting properties with them, whereas they go through parallel lines, which if you don't know what those are yet, we'll have the definition up there in a second. Okay? The first thing, the non-intersecting lines, that's just to give you a base for what we're going to do past that. That's just going to give you a couple definitions, and then we can go on to identifying something. So there's still going to be, the beginning of this is going to be a lot of identifying. And the end of it is going to be identifying, but you're going to have properties with it. So you actually will have some problems maybe where you solve for x's, finding angle measure seconds. So you start with the non-intersecting lines. So lines that do not intersect, they don't touch, no point of intersection with these. There's two of them. Okay? One of them is the parallel, which most people are familiar with even before they get into a class like this. Not everyone, but you know, a lot of people are. And the other one, the word was actually on, I think, the review packet for the last chapter. The word came up, and that was skew. And I think a couple of people asked me about it. But for the non-intersecting lines, they're technically equivalent, parallel, and skew. Now, you guys, I will ask you guys in one way or another about the definition of these lines. Like I'm going to say, you need to know the difference between them. Like the idea that they both don't intersect should be something that is just an easy property for you to remember, or something that you should automatically say every time. Remembering the difference between the two, since there are two of them, you are going to have to explain to me at some point, on test, quiz, somewhere. Okay? So definition-wise, parallel lines don't intersect and they're coplanar, right? Coplanar meaning they sit on the same plane. So in this essence, here's the thing, if you want to check these, if I ever have a question where it's like, are these lines parallel? You know, and it's just a basic identification. I'm not saying prove it or anything like that. Parallel, guys, you got to remember, coplanar means they're sitting flat. Like you imagine them both sitting on the one sheet of paper. And if they're both going the same direction, then they don't intersect. Now, I'm going to use that a few times here with the identification stuff, with the whole going the same direction. But please don't put that on the test. Like if I say, what's the definition of parallel lines? Don't say something like lines that don't intersect and go in the same direction. I'm not going to give you credit for that. Like I'll give you half credit for the non-intersecting part. Okay, but that's not going to be something you want in the definition. That's more just something you'll check. Okay, so parallel lines, you want to draw an example out. They don't intersect. Essentially, they're going in the same direction. When you have lines that are parallel, and I'm just going to call this line A and B. The way this is marked on a diagram, if they want to identify two lines that are parallel, they'll put like a little arrow on the line somewhere. So if you see that little arrow somewhere, that means that they're parallel, so they're never going to intersect. And if you actually write out in words, like if you have to identify, if you write out in a sentence form that those lines are parallel, there's a symbol for it, okay? So if I wrote out that line A is parallel to line B, so line A, line B, if I wrote they're parallel, the symbol used between them is just, it looks like basically an 11, but usually it extends beyond the bottom of the line a little bit. So it's like so just so it doesn't get confused with an 11, all right? So it's just putting parallel lines between them. So this would be how you note, like how you actually write out line A is parallel to line B. And the reason this has symbols is because parallel is going to come up a lot. Because when we have parallel lines, there's going to be properties that follow through with it. Such as like we're going to have congruent angles here in a second, so you'll see, you know, And remember, I keep saying congruent things are very good within the next step. Okay, now the skew lines. The difference between them is skew lines aren't on the same plane, so they're non-coplanar. And I will ask you the difference between them. And when I ask you the difference, I'm going to be looking for the fact that one of them is coplanar, one of them is non-coplanar. Okay, now, in order for you to check, skew lines are going to be going different directions. Now, since it's not coplanar, you're no longer thinking about a flat piece of paper. You're not thinking two-dimensionally. So skew lines usually get some people because of the fact that you have to think three-dimensional. The only way you can have lines that don't intersect, that aren't on the same plane, would be one that's maybe going this way. And then just so you can sketch it out the way it would have to be sketched out would be another one. And then what they do is that they get close to the dashes. So the dash part means that it's basically passing underneath the other line. All right, so they're not going the same direction. And again, I don't want you to use that in the definition. That's more of an identification thing. But if you see something dashed, or if they put it on like a box gets used a lot for your testament. As long as they don't actually cross, like one goes underneath the other, or one goes in, in the room behind us, the other one's going up and down, something like that. As long as they don't touch, they're technically skewed.
So if the dotted line means they're not intersecting.
Yeah, it's like they're like hovering over each other, like that. And yeah, dash will always mean it's going down or under or something. Okay, now, so for identification purposes, a lot of times you're going to have, and you'll have problems. For tonight, when they do name parallel lines, name skew lines, they're going to give you a diagram, basically a box. So that's the easiest one to deal with in terms of identifying. All right. Down below, they've already listed some parallel ones, but there are some skew ones there also. Okay. So all the parallel ones would be the ones that run in the same order. Okay. Now, what you got to imagine is on this box here, right? Every side, every face, that's a plane. So any lines that are on this plane that don't intersect are parallel. All right, this side right here, that's a plane. Any lines that are on this side right here, and that would be all the four sides that don't intersect are parallel. So they didn't list all of them down there. Like there'd be a whole bunch of pairs of parallel lines there. So like if I was looking strictly here, another pair I could pick would be like this line here, CG, that line, and I know this one over here are parallel. They're on the same plane, okay? They're basically on the same face, and they're not intersecting. One that usually gets people is that if you're dealing with a diagram like this, where it's boxed, this line here, this line are also parallel, even though they're not on the same side. There is technically a plane that goes through diagonally. It's just not drawn in there. So those lines going up and down are all going to be parallel with each other. Okay. Now the skew ones, if you listed like this, I have DC as one, and then EH. All right. They're not touching each other because this one's on the top, that one's on the bottom, and they're not going in the same direction. So that's like the easy way to check it, is to make sure they're not going in the same direction and they're not on the same level as each other. The top, bottom, left, right. All right, like I said, AD and BF. AD was on this side of the shape, BF's on the other side. And they aren't going in the same direction. That one looks like it's going back and forth, that one's going up and down. Okay? So, I'm going to do this real quick. See if we can get three. One pair here for parallel, one for skew, one for parallel. Well, don't worry about the parallel. Actually, don't even worry about it. I'm just worried about the segments right now. Okay, just do these. See if you can get one. Identify one and then see if it'll match up. So on this one, student parallel. I'm looking at AB. First off, can you tell me how many options I could have for putting this in here? Like how many pairs do you think I would form that are parallel? Three, right? What's one of them? Yeah. Another one. GH or that's all. All right. So what about the next one? Where it's skew? Okay, HD is the one in front.
Yeah.
Yeah. You guys agree with that one? DH is going up and down. It's on the front here. EF's on the back, so it's on a different kind of level. And is it going in the same direction? No. So that'd be one. What's another one? Which one? DC. FG, you said? AB. AC, because it's not technically drawn in there, but I can't create that signal. Are any others? EG, I can do that. Anything else? Yep. It's not in there, but I mean, I could technically create the segment, so I'd probably, I know it's not there, but I can make a segment that is going to be skewed to that one. So I wouldn't count on that. Yeah.
You wouldn't do AB and BC because that would touch it, right?
Yeah, they Okay, I think that's pretty much all those things. All right, now, so that's first part. Really, the main idea of this first one is just so you understand that there's different lines that don't intersect. We're going to focus mostly on the parallel. All right, so this is the main part of what we're talking about today. Okay, this again is going to be simply a definition first. Like this first part of it is going to be all identification. Okay, but this word comes up a lot, and everyone always asks. It sounds weird, but a transversal, guys, is simply a line. Okay, but it's a line that fits specific conditions. For a line to technically be called a transversal, it has to intersect two or more lines. Right? If you look up there, the last part says at different points. That's just so that you actually are creating a certain number of angles with this transversal. Okay, so something like if I did, here's two lines. They don't have to be parallel. Like, what's going to happen is we're going to have properties that deal with parallel lines in the transversal. And once we do that, people will totally forget about the first part and think that's the only way these are formed, but it's not. These lines that a transversal intersect do not have to be parallel. Okay? So this line right here going up and down, more up and down, that would be the transversal part because it's intersecting two different lines, two different points it's intersecting at. Okay, so it fits what the definition is. Now, if this would be the most basic one, like with two lines, I can have as many as I want going through there, all right? But for right now, you're only going to focus on that transversal intersecting two lines. Now, what's going to happen is at each intersection point, you can see there are 4 angles at each intersection point, right? Correct? What we're going to do is there's going to be a name. We're going to start pairing those angles up, and there's names for each one of the pairs. So, and when I say pair them up, I mean like I'm going to take one angle at the top point and pair it up with one at the bottom point. Okay? And as you do that, there's 4 different classifications it could fall into. All right? And those 4 for right now are simply going to be identification stuff. Then at the end, when we do the line, the lines that it's intersecting in parallel, they're going to be properties go with it. All right? Just kind of keep that in mind. Okay, now, these angle pairs. If you look on the picture right there, in between these lines, it's kind of shaded in, and it says interior, right? And everything else is considered the exterior. That's because these angle pairs, those words, interior, exterior, are going to be used in terms of the classification. Okay? Now, remember what I'm saying is, when I said the angle pair, right, I'm pairing them up. That means I'm going to pick one angle at this intersection point, and I'm going to pair it up with one down here. Now, the names of these things, the names of the pairs are going to be what's telling me which ones I'm matching together. All right, so first angle pair is called alternate interior angle. So if I ever see that term reference, like someone says, I'm looking at alternate interior angle, this is telling me I have a transversal. Like the way this works is you have to have a transversal, and I've paired together angles that are both on the interior and are on alternate sides of that transversal, so opposite sides. Okay? So, first thing I would do, if I was pairing this off, I'd say, look, if I need to identify alternate interior angles, I would identify first which angles are the interior. So my interior angles are those four right there. Okay? Now remember I said, when I'm pairing them up, I'm picking one at this intersection point, matching up with one on that side. Okay, now the alternate part, alternate means I'm picking one angle on, essentially with the way this picture is drawn, I'm going to pick one on the left side, match it up with one on the right side. Okay? So for example, one pair that would match up here would be like angle 4, right? Because angle 4 is an interior, it's on the left-hand side, and I would match it up with angle 6. All right? Because again, I'm picking one up here and matching up with one here. So angle 4 is on the left, 6 is on the right. They're both on the interior, it fits what I'm looking for. All right, and then angle 3, 5. Okay? Now for the rest of these, it's going to pretty much follow that, with the exception of like corresponding. When we get there, it's a little different. All right, next one. This one kind of follows the same kind of idea. In terms of matching it up, same kind of idea. So this is alternate exterior angle. Again, alternate means I need to pick one on the left, one on the right, match those together. All right, and I'm only picking one angle at each intersection point. And I'm only choosing from my exterior angles, which are 1, 2, 8, 7. And what pairs do you think would fit alternate exterior angles? 1 and 7, and then 2 and 8. Okay, so 1 and 7 are on opposite sides. One's on the left, the other's on the right, and they're both on the exterior. So I'm going to 2 and 8. Okay. All right, the third one. And again, this is just identifying because I don't have any properties or anything with it. The third one, I'm going to have this corresponding angle. Okay, now this one's a little different because it doesn't involve interior or exterior. But the word corresponding in here, pretty much from now until the end of the book, if you see that word, corresponding, that means that essentially they're sitting in the same spot. For this one here, you have to kind of look at each intersection point and decide kind of, if you want to think in terms of quadrants, you can do that. Like, you know, when you did the XY axis, you had quadrant 1, 2, 3, 4. It's kind of the same idea. You want them to sit in the same kind of quadrant. For me, the easiest thing to explain us in the beginning is just to say, look, I'm pairing up one angle here with one down here. For it to sit in the same spot, I basically take all those 4 and just slide them down to the ones there. Don't rotate it, don't switch positions, nothing. Just slide them down. And whichever ones overlap with each other when you slide it down are the corresponding angles, because you're going to be sitting in the same spot. So if I took like angle 1 and I slid it all the way down over here, out of 5, 6, 7, and 8, which angle would it actually be overlapping with? 5. So I know angle 1 and angle 5 are corresponding. Okay? If you want to look at it differently, you can look up here and go, angle 1 is on the top and left. So down here, I got to pick the one that's on the top and left. So 1 and 5 are the same. If I do 3, 3 is on the bottom and right. Which one's the bottom and right here? 7. So that's just a different way to look at it if you want to identify. Okay? And there's 2 others, right? 2 and, which one does 2 correspond to? 6, and then 4 and 8. So either imagine this thing being slid down, and whichever one's overlapping the corresponding, or you can look at it as if you want to go angle by angle and go, okay, this is upper right, upper left, lower left, whatever. Okay, as long as you can identify, that's the main thing. All right, now the last one. This is same side, interior angles. Sometimes they'll call it as, they might list this as consecutive, but they mean the same thing. Same side is just a little easier to understand because we did alternate interior angles, meaning they were switching from left to right in terms of the transversal. Same side means they're on the same side as the transversal. Okay? So again, there's only 2 pairs here, right? Because there's only 4 interior angles, so I can only match them up twice. So if I look at them, if I said, what do you think is the same side interior angle with angle 3? 6. Because they're both on the right. And that would just leave 4 and 5 being the other. Okay, so these are the pairs you're going to be working with. These terms, especially this one and this one, are going to come up a lot within the next couple chapters. Those are the ones you definitely have to make sure you can identify. There's going to be properties to go with these in a second, but that's only going to be when these lines are parallel. That's a different thing. Right now, it's just identify. Okay? And that's what you're going to do for them, because I got a couple problems with what you guys do for class. As long as I can make this go away and go past it. Can I go past this? Right. This is in the book, the geometry book, guys. Okay? I'm going to keep our quotes when we're done if we aren't done already. Let's see, going through these. I'll do it by. So 1 and 2. What kind of angles are 1 and 2? Which one corresponding? Yeah. Right, so the corresponding ones, what about 4 and 3? Interior. And then 5 and 6. Corresponding. Okay. Over here, assuming it's the same, right? 1 and 2. 1 and 2 are which one? Same side interior. 3 and 4. Corresponding, and then 5 and 6. Corresponding. And then over here, 1 and 2, you get the corresponding. Here's the thing with this one right here. Okay, these are the 2 lines usually use. When there's more than 2 lines that transversal going through, it's easiest if you just got to imagine one's gone. Like 1 and 2, I only need to worry about that intersection point and that intersection point. That means you can just basically ignore that. If you just ignore it, then you can see it as being corresponding. And you kind of have to do that when there's multiple lines like that. Okay? So when I do the next one, like if I do 3 and 4, 3 and 4 at these 2 intersections. I have nothing down here, so I don't care about it. If I look at it there, 3 and 4 are which kind of angles? They're the same side interior. And finally, 5 and 6 is at the top intersection and bottom one, so you just imagine that one. The 5 and 6 are which kind? Alternate interior. Okay, it's easiest if you can do that. Like, you can just kind of ignore lines in there when you don't feel. Okay, now, this is the last stuff. But basically, guys, it's going to be rehashing what we just did in terms of identifications, but all it's going to do is put properties to it. Because as soon as you have 2 parallel lines that a transversal is going through, suddenly you're going to have angles that look exactly the same, Some that might add up to 180, things you can tie together. Now, most of these are going to serve as explanations because the things that are up here are postulates and I think there's one theorem. But when you go to use them as explanations, guys, I want you more to identify them as alternate interior angles, being congruent, alternate exterior congruent, whatever it is. Okay, I'm not going to name the theorems, I'm not going to name the postulates, so it's not that big of a deal. Okay? So what we're dealing with here is, with this stuff right now that's going to be up here, is you're going to have the transversal still, and 2 lines going through it. These 2 lines have to be parallel. Okay, so for everything that follows, in terms of a conditional, because everything that we're looking at now is going to be conditional between today and on Monday. So this would be like, it's got to start with if R is parallel to S. Like that has to be given in my hypothesis. Or whatever the names of those 2 lines are, they have to be parallel for everything to follow that we're going to put out. Okay, now, all 4 angle pairs have properties that go with them. If you just kind of look at this, because this is drawn to scale, okay, if you look at the angle pairs, you could probably reason up your own properties just by looking at it. Like, if I looked at this angle and that angle, right? Those would be your alternate interior angles, right? 3 and 7, correct? Right? Okay. Now, if I said look at them and just asked you, did you maybe come up with some kind of property about those 2 that you could write out? And when I mean properties, I mean like supplementary, complementary, congruent, that kind of stuff. What might you say about these 2 angles if I said just look at them and come up with something on your own? Give me a property that you might put that relates those 2 to each other. What do you think? They're obtuse. What else? Obtuse is a classification. That's not a property. Properties are things like what they equal, like how many degrees they equal. What's that? Well, if they're both obtuse, that means they're both bigger than 90 already. So if I added 2 numbers that are bigger than 90, it's going to be beyond 180 degrees. So it can't be that. Not necessarily vertical, but here's the thing. What's the property we have with vertical? Like, what was the point of having vertical lines? That would be they're equal. That's basically what this is. I mean, if you look at them, guys, they're going to be the same length. All right? So the way these things look are the same. Okay, so for all these right here, and I'm just starting with corresponding. I was just picking alternate interior, for example. Most of the properties, I mean, if I look at them, like 3 and 7, like I was doing, do they look like they're about the same size? It's because they are. The corresponding ones here. If I look at angle 5 and angle 7, do they look like they're the same size? Do they? 5 and 7. Yeah. They both look the same. They have to be equal. That's why these things, like the first couple that are going to be up there, guys, are going to be postulates. Because if you draw this out, there's absolutely no way for me to draw 2 lines that are parallel. It just do not create congruent angles with like the corresponding and alternate interior and alternate exterior. Yes.
Do you like that then?
You have what?
Do you like that?
I do. Here's the thing. Basically, what it's going to come down to is that you just kind of remember this bottom part. All right. Now, like I said, when you write out proofs, you give yourself kind of an explanation. I'm not too concerned with the postulate part. You remember that? As long as you remember corresponding angles are congruent. And remember, all of these start. These are all these right here. I'm going to have them numbered like 1, 2, 3, 4. They're all going to start the same way. It's going to say if a transversal intersects 2 parallel lines. If you have to have the transversal going through 2 parallel lines for these properties to occur. Because right before this, when you did the identification, you had a transversal going through non-parallel lines, and you had corresponding angles that were not the same measure. I mean, that's acute, that's obtuse. There's no way they're equal to each other. All right, but if you do have that transversal going through parallel lines like it's in the picture here, you're going to have those being congruent to correspond. Alright, so focus mostly on writing this stuff. And I've got it in parentheses, guys, because it's going to serve as an explanation. Alright? And I keep saying that because you're going to have problems. It's going to say, explain why. These are the words I'm looking for. Or if you're writing out a proof, and in the proof you point out that you've got corresponding angles that are congruent to each other, I expect that to be a reason. Okay? And like I said, you probably need to have somewhere that you're keeping track of all these postulates and theorems that have specific names, and just kind of use it as a word bank for when you're starting to do these proofs. So you have things to look back at just as a reminder of what we've already talked about. Okay? I'm going to start going through these a little bit faster. All right, so you got first thing, corresponding angles are congruent. All right, which would be all those. You can write them out if you want. The picture's not going to change. Okay? Second one, again, like I said, the whole theorem there starts out as the same thing. If a transversal intersects two parallel lines, that's the important part here. Okay, that has to happen for all these other things to happen, all these angles being congruent. All right, so now we've got alternate interior angles being congruent. Alternate interior angles there are 3 and 7, 2 and 6. 3. All right, the next one I'm going to have up there is alternate exterior angles. You think alternate exterior angles are congruent to each other? Why do they look at it? Tell me, are they congruent? Look at it. Yeah. 4 and 8, 5 and 1, they look like they're the same. So again, if it starts with intersecting two parallel lines, then alternate exterior angles are congruent. So essentially, right now you've got corresponding angles being congruent, alternate interior angles being congruent, and alternate exterior being congruent. As long as that transversal is going through two parallel lines. That part does not happen. None of those angles are definitely going to be congruent to each other. You cannot use that.
So we have to look for parentheses when we do it?
That's what I'll be looking for.
So they're in parentheses too?
No, you just write it out for it. That's just the name of it. Because I didn't put the name in the camera. Now, the only one that I haven't put up there in order, right, is the same side interior. Okay? If I look at the picture, right, my same side interior angles are angle 2 and angle 3 right there. Just looking at them, do they look like they're the same side?
No.
No. So that's the only one that doesn't fit the whole congruency mold. Like all the rest of them, corresponding angles, alternate interior, alternate exterior are congruent. Okay? Same side interior is the only one that's not. But you can kind of reason together what they are. Let me do this. These two angles together. Angle 1, what's angle 2? How many degrees should I get there? 180. This angle 3 right there. Are these two equal to each other?
Yeah.
And they're equal to each other because what kind of angle pairs are they that we just talked about? They alternate interior, corresponding, alternate, corresponding. So since these are corresponding angles, I know they're equal. If things are equal, can I just switch them in and out of the equation here? Am I allowed to do that? Like if I say 1 and 3 are the same, can I just replace 1 and put a 3 there? Yeah. That's the property that goes with the same side interior. They're going to add up to 180. All right, and the whole reasoning, the thing I just kind of talked to, that's the proof of it. I just didn't write it out completely 100% formally. It's just that's the way it's presented. Say it's something like 1 and 2 are a linear pair, so they add up to 180. But 1 and 3 are congruent because they're corresponding angles. Congruent angles are equal to each other, therefore I can throw that 3 in there in my equation, and I've got my property for the last bit. Okay, which is that. So your same side, consecutive and same side, remember, are the same thing. The same side interior angles are the ones that are supplemented. Everything else is congruent. Okay, so the problems you guys will be doing tonight are going to be things like, with this part, you're going to be finding measures of angles, you're going to be setting equations, solve for x's. Okay? Well, we're going to go through a couple before I give you the work for today. And the first one's going to be one where it's like, I'll have the picture up there, we'll give you one angle measure, and you find all the rest of it. Things are equal to each other, things are add up to 180, there's lots of ways you can go about it. Okay? And remember, guys, with the parentheses, that's your explanation. That's what I'll be looking for. Even on this one, I would assume people would go same side interior angles are supplementary instead of remembering it as interior. Forget that, that's not a big deal. If you actually write out the property that you use, that's fine. Okay? All right, can we go past this? No? No. All right, so this would be an example of one you might see. Okay, now, if I give you this problem, especially like on a test or something, I would give it to you and say, find the measure of all the numbered angles, but explain to me how you're getting each number. And since there are a lot, we've got all the stuff from chapter 1, chapter 2, and the stuff today, so you've got a whole bunch of things to pull from in terms of explanation. So if I gave you this problem and I say, look, find me all the angles, and I say explain each one, I expect multiple answers. Like, no one's going to do it exactly the same. Okay? Because you guys are all thinking in different order. All right? Now, could you tell me where you might start? Like, what was the... You get which one? Which angle are you getting if you do that? 2? So if I do, I'm not going to write out probably all the... no, I'm just doing it here just to say, show what you said. So you said do 180 minus 55 to get angle 2. So what's 180 minus 55? 1 what?
45. 125.
125.
Okay. Which one? Tell me. 6. So you're saying these two correspond, so they're equal to each other? Okay. 4? Why would it be 4? You got vertical angles, those are congruent. What else? 8? Yep. Now, yeah, because you've got like vertical angles here. These are alternate interior angles, so they're equal. These are vertical. Lots of ways to go about explaining.
How would you rate it?
You would just say each one. Like, measure of angle 2 was that. I said, look, that was because they're a linear pair. Then the next one you did was angle 6. So you said, oh, right, angle 6 was there. So then you said, oh, angle 6 is 125. It was corresponding. So you just, for each one, you would write out the thing next to it. Like, I wouldn't expect you to write out like a big formal proof of this. I just want, for each step you do, one thing on why you did it. Like when you did 2 and like when you got angle 4 here, say because they're vertical angles. That's been fine. You know what you're doing. Yeah. Yeah. You did a 2-column proof for that kind of problem, it'd be pretty long. Because even when I ask for, if I just say explain, I expect a quick one, a quick explanation like that, I'm really technically skipping steps that I would write out in formal proof. If you did a formal proof, there's lots of little things in terms of we'd have to switch from congruency to quality to substitute. It's more of a pain thing. So I wouldn't give you one like this for formal proof. Because it would be really, really long. Yeah.
Do you write like corresponding and all the names of the angles for every time you do a problem like that?
Only if you use them. But I didn't use them. Like I probably wouldn't bring up alternate exterior in this problem at all.
Oh,
I'm not going to write that in. Like, because I got around it without doing it. I mean, when we did it, we went, that was corresponding, like 4 and 8, that's what told me that.
so you still have to write out your steps and everything.
Yeah. But I would just expect it, if I said explain, I would expect you to write out which angle you found, and then just why. And that's it. Nothing more. Okay? All right. Same kind of problem here. Now, the difference is there's 4 lines up there instead of just 3. Suddenly, usually, like, freaks people out. But I told you guys on the classwork thing that was up there, was naming it. Eliminate some of the lines. Like if I was doing this, I'll go, okay, my given angle is right here. So I'm definitely going to use this intersection point. I'm not going to use this intersection point because those two aren't connected by a transversal. There's a line connecting those two. So I know right away to start with, I'm not looking at that. Okay, so for me to actually get this to a picture I was looking with, I need to either eliminate this intersection down here or this one. You want me to get rid of the 4 and 6 or the 5 and 3? 5 and 3, that's the first one I did. If I get rid of those, could I find out all those angles right there? Yeah, because then if I'm looking at it, and I know you can't erase the book, guys, but you can cover it up with fingers and stuff. If I was doing this and I say, I could explain it, I would say, well, that's 105, let's measure this angle down here. Because of vertical angle, correct? The measure of this angle. Why? You looking at these two?
Yeah.
Yeah, because they're what kind of angles? Corresponding. Right? 4 is how much?
75.
Because why? Which ones are 180? But here's the thing, if I actually explain it, okay, so if you did 4 and 6, you say these are linear okay. I could have done the same side interior there and been okay. All right, now here's the thing. I've got angles. I now have angle measures here and here. So it means if I bring back, say I bring back this part, all right, I'm no longer focusing on here. All I'm doing is looking at this part. So now I've got 75 here. Can I put a measure here? Yeah. 75. Those are alternate interior angles. 2 is also 75. I can, and then here's where the explanations could change. I could say, look, these are vertical angles that are congruent, or someone could say these are corresponding angles that are congruent. Both are correct. It's a matter of how you choose to explain it. All right, measure of 8 is what? 5. And then the last two are what? Angle 5 is how much? 5. All right. Now also remember, guys, the stuff we just did here, the only reason I'm allowed to do that is because these lines here are parallel, and those lines are parallel. If I didn't have parallel lines there, I couldn't do that.
So what would you do if they were listed?
I can't do it.
So that's not common.
Okay? All right, let's do the last one. Now, and just to show you how to transform these problems into what we want. So just remember, like everything we're working with parallel lines, hey guys, from now until basically the end of the book, outside of like a parallelogram kind of thing, and even with those you can do this. If you see parallel lines, try to create something that looks like a transversal going through the two parallel lines. Like obviously, that is a segment, so it's not extended beyond. That doesn't mean you can't go in there and add that part to it. Like I could on this side extend it that way and extend that one that way. I could then turn around and go, I can extend that and that. All right, and I could do that on each side. And like I said, the whole point of me doing that right now is just so I can resemble the pictures we had that went with the theorems and postulates. Okay, I wanted to look like that so I can match things up. So if I was doing this problem, again, I would look at, there's 2 intersection points there, there's 2 there. All right? I'm not going to do left to right because these lines are not parallel. So I wouldn't compare this intersection point to that one in terms of matching them up. I'm only going to do ones that are connected, or intersection points that are on the parallel line. So if I'm doing this, essentially you're doing 2 problems. All right, I'm looking at that one right there. And again, this is the matter of, guys, you just sitting there on your book and covering up lines with your fingers until you can see something that looks like a transversal. All right? Because if I just did that and I gave you that problem, if I just said, look, here's my problem, these are parallel, that's 2x, and that's x minus 12, it's essentially the same problem that was up there, it's just eliminating that one line. Okay? And then to actually do the problem, you would have to go in and go, okay, which kind of angle pairs are they? Like, which ones are they? Out of the four, right? Because right now we're focusing on the pairs of angles. The alternate interior, alternate exterior, and you put the same side interior. So you go, okay, the same side interior, now I've got to come up with the property that went with it. What was the property that went with the same side interior? What did they do? They added up to 180. That's the answer of how to set this up. So it's the whole 2x plus x minus 12 equals 180. Okay, so if I solve that out, what do I get? X equals 64. There I go, then go through the steps, right? 3x minus 12, 180. All right, now here's the thing. Would I do the same thing for this other part? Yeah, those are same side interior. If you eliminate that or cover it up, you're going to be left with those two having to add up to 180. And if I say why, you would say because those are same side interior angles. I got my parallel lines. This line right here is my transversal, so that means they're same side interior. All right, you said why? What? 40. Okay. All right, so in the problems where you solve for x's and y's, guys, it's just a matter of you identifying which pair of angles it is, setting up the problem appropriately, and just solving it out, like you would in algebra. Okay? All right, so that's the work you do tonight. Everything's in the workbook.